Okay guys, so this is part 2 of the review for the integrated 1 test number 3. Okay, so let's get started already. Number 14 says, Elaine has a business repairing home computers. She charges a base fee of $30 for each visit and $35 per hour for her labor. Okay, and then part A says, using the variable C for the total cost of a home visit and X for the hours of labor, write an equation that represents the situation. Okay, so C will represent the total cost of one visit. X represents the number of hours. Okay, so let's start with the numbers that they gave us. First, they gave us this 30. That's the $30 base fee for the visit. So if somebody goes over to, if she goes over to somebody's house, she's gonna charge them $30 no matter how long it takes, right? 1 hour, 2 hours, 0 hours. She's gonna charge $30. So that $30 is what we're gonna start with. $30 base fee. On top of that, she is charging $35 per hour. So to those $30, I have to add $35 per hour. And so remember what we said, if you see the word per or for each, that implies multiplication. So $35 per hour, that means times the number of hours. And we know from reading the sentence here that X represents the number of hours. So it's going to be 35X. And what is that total going to be? Well, the $30 of the initial of the visit plus the $35 per hour will equal the total cost, which is C. And you could write it, of course, the other way where C is on the left side. So it'll be C equals, we usually rewrite the X term first and then the constant, 35X plus 30. Okay, moving down says, create a table of values for the equation from part A. So you look at part A, which is the equation that we just found, and it's asking us to create a table of values for that equation. Okay, so choose some values of X, plug them in, and see what you get. Okay, I am going to start by plugging in, let's start with 0, 1, 2, and 3. Let's start with easy numbers. Okay, so we're going to substitute in 0, substitute in 1, substitute in 2, and substitute in 3 to see what we get for the total cost. Okay, remember X represents the number of hours. So what we're doing here is saying how much would it be for 0 hours, 1 hour, 2 hours, 3 hours. Okay, so let's do it. Let's substitute in 0 first. So I'm going to do it right here. C equals 35 times X plus 30. I'm plugging in 0. So 35 times 0 is 0, plus 30 is 30. So I get 30 for that one, which makes sense, right? That's her base fee, so if she works for 0 hours, she's still going to charge $30 for the visit. Okay, let's substitute in 1 now. Erase it right there. Put in a 1 instead. 35 times 1 plus 30, you can use mental math here. So 35 times 1 is 35, plus 30 is 65. Alright, let's do 2. Plug in 2, substitute in 2. 35 times 2 plus 30, that's 70. 70 plus 30 is 100. $100 for 2 hours. And finally, 3. 35 times 3 plus 30. 35 times 3 is 105. 105 plus 30 is 135. So 135. There you go. Let's do part C. It says graph the situation using the table from part B. Be sure to label your graph. Okay, so on the x-axis we are going to graph the number of hours, and on the y-axis we are going to graph the total cost. Make sure to always label your graphs when you guys are doing this. Okay, so the number of hours, 0, 30, 165, 2, 100, 3, 135. So the scale on my x-axis, I'm just going to go by ones. So on. For the y-axis, I'm going to go by, what would be good? I want to get all the way up to 135. So I think if I go by 15s, that should work. So let's go by 15s. 30, 45, 60, 75, 90, 105, 120, 135. See, that should work perfectly. And then 150 will be the last one. Okay. And remember, this represents the cost. Okay, so 0.30. 0.30 will go right here. 165 will go right between 60 and 75, but closer to 65, so right about there. 100 will go between 90 and 105, but closer to 105, so right there. 3 is 135, so way up here. Okay, there is my graph of the situation. And finally, it says explain in complete sentences whether the graph above is discrete or continuous. This is open to interpretation, right? So discrete means that you are only going to plot those points and you're not going to connect them, okay? And we do that when it doesn't make sense to cut up the information into smaller pieces. For example, if I cannot divide up the number of hours, I have to work 0 hours, 1 hour, 2 hours, or 3 hours, then it has to stay discrete, okay? But if Elaine is able to cut up her time and say, you know what, it's okay, I'll charge you for 15 minutes, I'll charge you for 10 minutes, I'll charge you for 30 minutes, then that would make it continuous. Okay, so that's actually open to interpretation. I'm going to go with the usual interpretation here, which says that Elaine is going to work charge per full hour only, which means that it's going to be discrete. Either you say discrete or continuous. The point is that you explain in complete sentences why you think that is the correct answer. Okay, discrete. Why? Because she can only charge for full hours. And somebody else might say continuous because she can cut up the hours and charge by pieces of an hour, okay, by fractions of an hour. Okay, number 15. The table shows the height of a baby giraffe for a given number of months. If y represents the height and x represents time in months, write an equation in point slope form. Use the point 476. Okay, so I need to label these x and y first before I do anything else. Y says here represents the height, okay, which means that this is y over here, the right column. X represents the time, which is this one, so that's x. It's going to help me actually write the point slope form, and that way I don't get confused on which one's which. Okay, so it says write the equation in point slope form. So before you write any equation, the first thing you always should figure out is what is the slope, right? So we need to figure out the slope here from the table. I'm going to figure out the slope by finding the rate of change, the change in y versus the change in x, right? So what you need to do is figure out from 76 to 97. And by the way, I'm using these 2 points right here, but you could use any points on your table to find the slope, right? I'm using 76 and 97 and 4 and 7 here. The question is from 76 to 97, what's the change? Okay, what's the rate of change? How much did y change by? So you could think of it as a subtraction problem, or you could just think, oh well, 76, in order to get to 97, how much do I need? Okay, and the answer there is 21. Positive 21, right? From 76 to get all the way to 97 is 21, plus 21. Do the same thing on the left side for the x's. From 4 to 7 is plus 3. Your slope is rise over run, or change in y over change in x. So your slope is 21 over 3, which is going to give you 7. The slope is 7. And then from there, you just plug it in, substitute it into the point slope form. Okay, y minus y sub 1 equals m times the quantity x minus x sub 1. And I'm going to plug in something for y sub 1, and I'm going to plug in something for x sub 1 right there. And what am I going to use? They told me to use this point 476, so I have to use that one. Okay, so for x sub 1, what you need to do for that point is label it. This is x sub 1 and this is y sub 1. So for x sub 1 I'm going to plug in 4, and for y sub 1 I'm going to plug in 76. Okay. Once I substitute in those values, I can now simplify it. There's really not much to simplify. You can actually just write it again to make it clear. Y minus 76 equals m, which is 7, times x minus 4. And there's your solution. Is it in point slope form? Yes, it is. And did I use the correct point? Yes, I did. Okay, you can use any of the points. Okay, you don't have to use 476. It's just the problem is asking you to use that one so that everybody uses the same point. Okay, here we go. Number 16. The table shows the cost of a Disney annual pass for a given number of people. Okay, so here's a table. For 2 people, it costs $660. For 5 people, $1620. For 6 people, $1940. For 10 people, $3220, and so on. Okay. First question is the rate of change constant? When they ask you that question, is the rate of change constant? Find the rate of change and see if it's the same everywhere in this table. So, for example, from 6 to 1620, what's the change? That's what you got to figure out. How much did it change by from 660 all the way up to 1620? And so what you can do in that situation is use mental math or just simply subtract one from the other so you could figure out what the change is. So let's subtract 1620 minus 660, which gives me 960. Okay. From 1620 to 1940, what's the change? So once again, you could think of subtraction, or you could just use mental math to see how much it changed by. From 1620 to 1940, we use mental math in this one, and it's actually 320. And the last one, from 1940 to 3220. 1940 to 3220, use mental math or just go ahead and use subtraction on a calculator or on your paper. 3220 minus 1940 gives you 1280. And so at first glance you might think, oh, then it's not constant. I'm getting different numbers everywhere, okay? But we haven't done the left side. We haven't done the change in x yet. You have to do this one too so you could actually find the rate of change. So from 2 to 5, that's plus 3. From 5 to 6, that's plus 1. And from 6 to 10, that's plus 4. So all of these are positive, right? And now to find the rate of change, what you do is you're going to make a fraction. Remember, rate of change is change in y over change in x. So 960 over 3. The other one is going to be 320 over 1. And the other one is going to be 1280 over 4. And what you got to figure out is, are they all the exact same thing? Okay, so do those calculations. So for example, this one in the middle, 320 over 1, that's easy, it's just 320, right? So the question is, are the other ones also going to give me 320? Okay, so divide 960 divided by 3. And you could do that division on your paper or you could do it on your calculator. 960 divided by 3 also gives me 320. So that just leaves the last one. Is 1280 divided by 4 also 320? Okay, and once again, do it on your paper, do it on a calculator. You should come up with 320 as well. So the answer to the first question is the rate of change constant is yes. Yes, it is. And the second question says describe what, it should say what right there, describe what the rate of change represents per person. Okay, so what does that 320 represent? It represents how much each person's Disney pass costs, okay, how much it increases per person, okay. The cost of the pass increases by 320 per person. Okay, 17. Northgate Market sells Monster Energy drinks for $2.29 each and Hot Cheetos for $1.99 per bag. Write an equation in standard form for the number of Monsters, which is M, variable M, and Hot Cheetos, C, that you could buy with $18. Okay, we could write an equation And an equation means that we're going to spend exactly $18, but we could also write an inequality to say that we could spend at most $18. Okay, so I'm going to do both. Northgate sells Monster Energy drinks for $2.29 each. So the Monster Energy drinks represented by M are $2.29 each. Okay, M is the number of energy drinks that you buy, and $2.29 is the price per Monster. So the total amount that you pay for all of the Monster Energy drinks that you buy is $2.29 times M. So for example, you could plug in different values for M. If you buy 0 energy drinks, then it's $2.29 times 0, which means $0. If you buy 1, then it's $2.29 times 1, which is $2.29, and so on, right? The Hot Cheetos are going to be represented by C. That's the number of Hot Cheetos that you buy. Each one is $1.99, so we're going to multiply by $1.99 to find the total cost of the Cheetos. Okay, so this part right here represents the total cost of all the Monsters you buy. This represents the total cost of all the Hot Cheetos you buy. So you want to find the total cost between both of them, you add them together. Okay, and it says that you have $18 to spend. So you want to spend exactly $18. You say the cost of the Monsters plus the cost of the Cheetos is going to be equal to $18. Okay, and that's what we did earlier in the chapter. Towards the end of the chapter, we talked about inequalities. So you have $18. Maybe you have $18, but you don't want to spend the whole thing, right? You want to spend at most $18. That's all you have. You could spend less than that, but not more than that. In that case, our inequality would look like this. 229M plus 199C. And what we say in this case is that that total should be less than or equal to $18. Okay? So it depends on what the situation is. You're going to use an equation or an inequality. And both can be graphed. Okay, number 18. Leslie joins a fitness club that has an initial fee of $20 plus a monthly fee of $15. Rashad's club charges $40 initially plus $10 per month. In how many months will the clubs cost the same? Here's the clue on what you need to do. In how many months will the clubs cost the same? Okay, let's call X the number of months. That's what we need to find out, right? The number of months. That's X. And there's two clubs. There is Leslie's club and there's Rashad's club. And we want them to be equal to each other, right? That's the question at the end. In how many months will the clubs be the same? So let's focus on Leslie's club right now. Leslie's club says that it charges an initial fee of $20 plus a monthly fee of $15. Okay? So an initial fee of $20 plus a monthly fee of $15. Since that fee is monthly, we're going to multiply it times the number of months, 15x. Once again, the 20 is the initial fee, but this one is being charged every month, so 15x. Rashad's club is 40 plus a monthly fee of 10, which means 10x, 10 per month. And there's the equation. We can solve it to figure out how many months it will take for them to be the same. Okay, so if you want to solve this, the way that I always think about these types of equations is I have x's on both sides, and that is not right. Okay, that's not possible. The x's always want to be together. They belong together. Okay, so what you need to do is either subtract 15x to get rid of it here, or subtract 10x to get rid of it here. Either way, they have to be together. They can't be on opposite sides, okay? So I'm going to go ahead and subtract 10x from the right side, which will make it go away from the right side. But I have to do it on the left side as well, okay? So the 10x and the negative 10x cancel. On the left side, 15x and negative 10x become 5x. And the 20 comes down. And on the right side, all I have left is 40. Okay. Now what I'm going to need to do is isolate the x. So if I want to isolate the x here, I need to get rid of the 20 and then divide by 5. So first get rid of 20 by subtracting it. All right, we're using inverse operations here. Leaves me with 5x equals 20. And finally, I'm going to divide by 5 on both sides, and that'll leave me with x equals 4. So in how many months will the clubs cost the same? In 4 months. Okay, you want to test that? Let's test it. Okay, how much will be Leslie's club in 4 months? Well, it's going to be 20 plus 15 times 4, right? 20 was the initial fee plus $15 per month for 4 months. So that'll give me a total of 15 times 4 is 60 plus 20 is $80. That's going to be Leslie's club. Rashad's is going to be 40 plus 10 per month, but we say it's 4 months. 10 times 4 is 40 plus 40 is 80. And you can see that in 4 months they're both going to be exactly the same, which is $80. Okay, number 19. The graph shows the daily sales goal of a coffee shop. If the employees sell 20 cups of coffee, how many cups of tea must they sell to meet their goal? Okay, so here's the graph that represents the cups of tea and the cups of coffee. Okay, as long as they sell the numbers that are on this line, then they will meet their goal, their daily sales goal. So for example, I see right here that if they sell 40 cups of coffee, then they can sell 0 cups of tea and it's still okay as long as they sell 40 cups of coffee. Or up here on the y-axis, they sell 50 cups of tea, then it's okay if they sell 0 cups of coffee because they sold 50 cups of tea. Okay, so the question is, if they sell 20 cups of coffee, right there, 20 cups of coffee, how many cups of tea do they have to sell? So what you do is you look on the axis that represents the cups of coffee, which is the x-axis right here. Look for the number 20, which is right here, and then work your way up this way until you find the y value at that particular point. Okay, so here's what we're going to do. We look for 20 right there. We're going to go up and we figure out what is that point for 20 cups of coffee. How many cups of tea are at that exact point where the line intersects 20 cups of coffee? And you should be able to see that if I go this way, it's between 20 and 30, exactly between 20 and 30. I think I just went slanted. So we're going to say 25. If they sell 20 cups of coffee, they have to sell 25 cups of tea. All right, let's move on to number 20. Jessica decided to run home from her friend's house, which was 12 miles away. So there's the graph right there for Jessica's running home. Okay, so the x-axis represents the time, and the y-axis represents her distance in miles from her house. Okay, so first question, find the slope of the line. Right, you're going to find the slope of a line. Find 2 points that are on that line so that you could find the slope. Okay, you could also do it by counting, making a slope triangle and counting squares. However, I prefer to just find 2 points and use those 2 points to find the slope. So I'm going to go ahead and look for 2 points that are on my line. Okay, I see very clearly the y-intercept. That's a point I can use, 0, 12. And I also see very clearly the x-intercept. That's another point I can use, 3, 0. Using those 2 points, I can find the slope. Okay, find the slope by finding the rate of change. Okay, I always stack them together like this, and then I just find the rate of change, either going up or going downwards, going upwards or going downwards. It doesn't matter. Just find the rate of change. So look on the right side, 0 and 12. From 0 to 12, I'm trying to go from 0 to 12. What is the change there? Okay, how much did it change by? And you should say by 12, right? That's plus 12. From 3 to 0. How come I'm not going from 0 to 3? Because I already went from 0 to 12. So I have to do the same thing on the left side. From 3 to 0, what's the change? And there you should say minus 3. Right? From 3 to 0, it's negative 3. Your rate of change is the slope, which is change in y, which is 12, over change in x, which is negative 3. So you're going to write 12 over negative 3. Simplify it, and so your slope is negative 4. There's the answer to question number part A. Moving down, part B, find the x-intercept and explain what it represents in the context. We already did, right? It was one of the points that we found. However, if we didn't use that point, we could easily see the x-intercept by just looking at where the line crosses the x-axis. So the x-intercept is 3, 0. What does it represent in this context? Okay, so we're looking at the graph here. The x-axis is the time, and the y-axis is the distance from her house. So if I look at 3, 0, 3 is the time in hours, 3 hours. 0 is the distance from her house, 0 miles. So what it means here is that in 3 hours, she'll be 0 miles from her house, which means that she is home. She'll get home. Or you can say she'll get home in 3 hours. Okay, moving down. Find and interpret the y-intercept. So do the same thing now for the y-intercept. Good thing is that we already found it. If we didn't use those points though, it's really easy to see the y-intercept. Look at where it crosses the y-axis. So it's 0, 12. And once again, interpret it. 0, that stands for the number of hours. 12 stands for the number of miles. So in 0 hours, she is 12 miles from home. So this means that at the beginning, or when she first starts running, it's right at the beginning or initially, she is 12 miles from home. Okay, part D, find the reasonable domain and range for this situation. Okay, what's reasonable in the domain and the range? Domain, think x values. What are the possible x values that I can use here? Okay, so I can use, if she's starting to run from to her house and she's 12 miles away, the initial x value is 0, right, 0 hours. And the final x value, which is when she gets home, is 3. Okay, so the x value, which is the time, is somewhere between 0 and 3. So we always write it in this form, right? X is somewhere between 0 and 3, which is 0 is less than or equal to x is less than or equal to 3. That's the domain. The range, same idea, but now we're looking for the y values. The y values in this case represents her distance from home, okay? How far she is from home. So how far could she be home from home? The least amount is 0 miles. That's when she is home. What is the largest amount that she is from home? 12 miles. That's where she starts running. And your y value is somewhere in between those two. Okay. Instead of y, we can also write f of x. Function of x, which is y. Both of those would be correct. Okay, and finally part E. Write an equation for the line in slope-intercept form. Okay, now you want to write an equation in slope-intercept form. You have two options. You can start with slope-intercept form, but you also have the option of starting with point-slope form. Both will work. Both will get you your answer. Okay, let's do both just so that everybody can see how you can do it in both ways. Starting with point-slope form. This is the one that I think most people find more familiar or easier to work with. Okay, so let's go with point slope form. Let's plug in everything that we have, all the information that we have. We know m. We found it earlier, right? The slope is -4. It's right here. We also need a point. We need an x sub 1 and a y sub 1, and we have two of them. We have 3, 0 and 0, 12. Use either one of those two. Substitute them into point slope form, and you should be able to come up with your equation. So here we go. We know m is -4. And we need to plug in an x sub 1 and a y sub 1. I'm going to go ahead and use 3, 0. Okay, so x sub 1 is 3 and y sub 1 is 0. We're going to plug those in. So x sub 1 is 3. That goes here. y sub 1 is 0. That goes there. Okay, so you have it in point slope form. Now what you got to do is just distribute to turn it into slope intercept form. So it'll look like this. Y minus 0, right? It's y minus 0, but do I really need to write minus 0? No, I don't. I could just write y equals negative 4x. You're distributing in this case. Negative 4 times x, negative 4x. Negative 4 times negative 3, because it's minus 3 right here, is going to be positive 12. And there you have it. Okay, using point slope form. Using slope intercept form might be easier and faster for some of you guys. Why do I say that? Because we know m is negative 4. Also, we know b. You got to recall what b stands for. B stands for the y-intercept. We know the y-intercept. We just found it earlier. Okay, the y-intercept is 12, right? 0, 12. So b is 12. And therefore, since you know that m is equal to negative 4 and b is equal to 12, you can just substitute them into your slope-intercept form, right? mx plus b, plug in m, plug in b. M is negative 4 and b is 12. And there it is. It's the same equation we came up with when we used point slope form. Okay, 21. The American Cancer Society is selling water bottles for $8 and tote bags for $12 to raise $240 to donate to charity. Write a linear equation in standard form for the fundraising goal. Okay, so it says a linear equation, but once again, since we have a goal of 240, we can also use an inequality in this case. So let's do both an equation and an inequality. For an equation, what you need to do is come up with a variable to represent the tote bags and a variable to represent the water bottles, right? A variable to represent tote bags and a variable to represent water bottles, okay? Since down here I can see that I already have a graph that has an x and a y, and x is water bottles and y is tote bags, I'm going to stick with that so that I don't get confused later. So x will be the number of water bottles and y will be the number of tote bags. Let's write that down so that I don't mess up and forget, okay? X will be the, once again, water bottles. Y will be the tote bags. The number of water bottles sold. And Y will be the number of tote bags sold. Okay? So using that information, now I can come up with an equation, right? Let's start with the water bottles, X. The question first is, how much are those water bottles? Okay, and it says here that it's selling water bottles for $8 each, right? So what I'm going to write is 8x. Why 8x? Because $8 per bottle, so 8 times x gives me the total amount raised in water bottles. To that, I am going to add how much they raise selling tote bags. Each tote bag is $12, so we're going to write 12 times the number of tote bags, which is y. So once again, let me explain what this means. X is the number of water bottles. $8 each is 8x, right? Total money raised in water bottles. Y is tote bags. 12y is the total money raised with tote bags, okay? The goal to raise is 240. So if I add this plus this, I should get 240. Okay? 8x plus 12y is equal to 240. We could also make an inequality of this. Although the instructions say an equation, if you want to raise 240, once you raise 240, are you going to stop selling? I would say no, right? You want to raise at least 240 and go above that. So if I want to change it to an inequality, then it would look like this. 8x plus 12y is greater than or equal to 240. Because sometimes we want more, right? We're not going to be satisfied with only $240. Okay, both are correct depending on what you're looking for. Now, since this one says equation, not inequality, then this would be the technically correct answer, okay? But this would also be correct if you want to go over 240. All right, next part B, complete the table. If you sell 0 water bottles, how many tote bags do you need to sell? So we're going to use the equation that we just wrote right here, substitute in these numbers to see what we get for the other one. Okay, so 8x plus 12y. Now, you know what? We're going to plug in x. So you know what? Let me erase this and start again. 8x plus 12y equals 240. But I'm plugging in, substituting in 0. So 8 times 0 plus 12y cancels out. So 12y equals 240. Solve for y, divide by 12. And so y is equal to, use your calculator if you get confused here, 20. What does that mean? It means that if they sell 0 water bottles, they still want to raise 240, they have to sell 20 tote bags. Okay, let's do it for the next one. Missing the missing the number of water bottles, but it does have the number of tote bags. So let's erase right here and do the work right here. So in this case, I need to plug in 0 for y. So substitute in 0 for y. So it's 8x plus 12y equals 240. Y in this case is 0. So 12 times 0 is 0. So all you have is 8x, right? This cancels out. 8x is equal to 240. Divide by 8. Divide by 8. And so x is going to be equal to 30. So what does that mean? It means that if they sell 30 water bottles, then they can sell 0 tote bags and still make $240. Or if they sell 0 tote bags, they have to sell 30 water bottles and make $240. Okay, let's do the last one. Erase this one right here. So now what we're doing is we're substituting in for x water bottles, 15 in for x. Okay, so it's 8x plus 12y is equal to 240. 8 times 15, we're plugging in 15 for x, plus 12y is equal to 240. 8 times 15, use your calculator if you need help with that one, it's 120. Plus 12y equals 240. And now I need to solve for y. I'm going to subtract 120 from both sides, right? Inverse operations here. So when I do that, I'm going to get 12y is equal to 120. And then I'm going to divide by 12. And so y is equal to 10. So if they sell 15 water bottles, then they need to sell 10 tote bags. All right, table's done. Let's move on to the graph. So I'm going to leave the table there so that I can see the numbers that I need to plot. Since I already have the table, I can just use those to make my graph. So first, 0, 20, 0 water bottles. That means 0 here, 20 tote bags all the way up there. I need to put a point right there. Next, 30, 0. 30 water bottles, 0 tote bags. I need to put a point right there. Next, 15, 10. Okay, 15 water bottles. It's going to be here, and 10 tote bags is going to be right there. And there it is. There's my graph. I'm going to connect them right there. Any point on that line represents the number of water bottles and tote bags that I can sell and make $240. Okay, if I want to make more than $240, then that would mean that I would need to use any point above this graph. Okay, if it was an inequality, I'm saying. So any point above or outside that graph would give me the $240 or more. Any point below the graph down here would not give me $240.